Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I am Charlene O'Hanlon and the moderator for today's event, and I welcome you. We have a great webinar on tap. I am super excited about this one, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have a demo today, which I'm really excited about, as always. And at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Deliver Your App Anywhere, Publicly or Privately. Our speakers today are Pranav Dharwadkar, who is VP of Products at Volterra, and Jakub Pavlik, who is Director of Engineering at Volterra. Welcome, gentlemen. Thank you so much for joining me today. Really appreciate it.
Thank you for having
Pranav,
us.
I know you are, yeah. Well, if you weren't here, we wouldn't be doing a webinar. So thanks for joining me. I'm going to take myself off camera, put myself on mute, and let you guys get right to your conversation.
All right, can you hear me and can you see me and can you see my slides okay?
Yes.
All right, awesome. All right, so thank you everyone for joining us on this webinar where we'll be talking about how the needs for modern applications are changing, how applications need to be delivered, and we are showing you what it takes to deliver your app anywhere, both publicly as well as privately. So the trend over the past many years has been for developers to adopt new approaches in order to deliver their new services faster. The first trend was users were going from the private data center to the public cloud, because that is what was helping them adopt new technologies to help them move faster. They can provision a VM faster, just a click of a button, and they can deploy their app. What they're now doing is, all right, now that I've gone to one hybrid cloud, they're now doing multiple public clouds, or even the network cloud as well as the edge, so that they can actually develop new services faster and they can deploy these new services faster. The second thing that the developers have started adopting is they're going from monolithic applications to virtualized applications. So they put stuff in a VM, and then once it's in a VM, they can move the VM in different locations and they can deploy an app faster. But what is happening now is that they are moving not only from VMs, which take up a lot of resources, to actually microservices and containers, which are very lightweight. And now once you define a container, you can now deploy that in different environments easily. And that's what developers are using in order to deliver a new service faster. Furthermore, from containers, they're actually going to from microservices, they're actually going to serverless as well in order to go really fast, so that they don't have to deal with the underlying server complexity. They just write their application code and business logic, and that's what they deliver. And then instead of having like a regular a fixed cadence, everything is happening continuous integration, continuous deployment, and continuous delivery. And not only that, continuous verification, so that they can continuously monitor their applications as soon as they deliver it. But the problem when deploying an app, delivering an app to a user, it requires multiple components in order to deliver the app. You first need to obviously, you need to set up a either a cluster or a VM for your application. Once you deploy and set up your your Kubernetes cluster, you then need to set up your ingress controller so that your app can now be accessible from the outside. Once you have that, then you now, since your app and API is exposed from outside your cluster, you now need to have a web application firewall so that you're protecting your app, you're protecting your cluster, right? Now this is all in your domain. This now has to be advertised publicly. So you now need to deploy a load balancer, a network firewall, a router, and a DDoS in order to deliver the app that you deployed over here. You need to deploy that all the way to the internet. You need to deploy all of these different components. So the developer has to go to his or her business partners who are DevOps, which may be in the same organization, or network and IT, which is now called infrastructure and operations, which could be in a different organization, in order to deliver an app. And usually the communication between the DevOps and network and IT is using support tickets. And there's usually not one, but several of these support tickets because there are so many different components, and each of this is iterative, right? So you can probably do a support ticket, you get back something, you have to test it saying, this is not right, I need to do it again. So this thing is an iterative process that takes a lot of time. The impact of this on the entire app delivery process is that the developer is going fast by adopting these modern application architecture approaches such as microservices, serverless. The developer is actually developing faster, but delivering the app or the service that the developer delivered, delivering that to where it can be consumed by an external user or a client, takes up a lot of time from both the DevOps and your network and IT team, because these processes are still slow, the tools are still slow, and this is negating all of the efficiencies that are gained by deploying a modern app. So now let's take a look at why does it take so long to deliver an app publicly? What are the different components? The first thing that you, as I said, for an app, you need to first create your Kubernetes cluster or your VM, and that that's pretty fast. That's about 1 or 2 days. You can just deploy a cluster with the infrastructure as code. You're actually doing that really quickly. Then you need to set up your ingress controller, and then usually users do they look at the internet and see other examples of this, and that also is pretty fast. It's about 2 or 3 days, right? So in 1 week, you can actually, have your app set up within a cluster and be able to ensure that traffic comes in from the outside. The problem comes in when you're now needing to secure and deliver your app to the internet, right? So when you're delivering an app publicly or API, you need to set up an app firewall. That takes a while because you need to tune the app firewall. You need to make sure it is configured correctly. That the app firewall tools that are used right now are pretty onerous. They're not user friendly in terms of their way they are configured or rules to block and so forth. Then you need to assign a virtual IP that you terminate on your load balancer, and you need to ensure that this is connected to your backend. This is all done from DevOps to your infrastructure and operations team, and that takes each takes about 1 or 2 weeks, because using the support ticket mechanism to actually create a request, you actually get something back. Then you see, all right, this is not working. I need to open up maybe some other port, or I need to secure this traffic, and so forth. This iterative fashion actually takes sort of 1 or 2 weeks for each of these different components. And then lastly, when you go to DDoS, that is not in your network, that's actually outside your network. You're actually going to like a external DDoS provider. Again, their system is completely different. And there you need to set up the whitelist rules and sort of where the traffic comes from. You need to do a public IP and all of those. And that takes some time as well. So total, if you look at all the time taken by all of these different components, it's about 7 to 12 weeks for you to deliver an app publicly. Now, if you take the same example where, okay, I want to deliver the app publicly, but I may have, for example, I may have users who are coming in from the internet, but I also have partners where I need to deliver my app or API privately to my partner. So this may be a premium partner, for example, where I need to deliver my app, or this could be, for example, an edge, where this is like a branch office, for example, or a retail store where my API needs to be delivered, needs to be accessible from the edge. For example, if the edge wants to access a centralized database or wants to access a centralized service, that's an app or an API which needs to be accessed from the edge. These are all examples of delivering an app privately. In that case, all of these other components remain the same, but the big component is now a private link. So, for example, say you are in your private data center and you have uh, um, uh, a microservice which is running in the public cloud, maybe a machine learning service, or maybe this could be using a web service such as analytics or and so forth. That may be residing in your public cloud. So in order for this apps over here to communicate with apps over here, and you want it to be a private connection so that you're not exposed to the internet, there you need to set up a private link such as direct connect or express route, and so forth. And that requires you to first configure VPNs on both sides so that you have the VPN connection, but you also need to set up the private link connectivity going to your to your connectivity provider in order to get that. And that, in addition, takes 3 to 4 weeks in order to do that. So delivering an app privately takes longer and takes about 9 to 15 weeks if you add all of these up. So if I take a step back and look at all of these different components and ask myself, is this what a modern application needs or requires, right? You've made your app development fast, but the delivering process is still slow because there are so many products. How do you come up with a way, or what is the best way to deliver an app easily and quickly, right? In that case, what needs to happen is let's look at the problems and let's look at what a new approach should be employed in order to deliver the app. The first thing is there are multiple point products, right? If you look at all of these different products, there are multiple point products, right? And that contributes a big factor to taking a long time. The second thing is it's not only multiple point products in one location, which is your private data center, for example. Now you're deploying the app in multiple locations, your private data center, your cloud, your edge, your network. Each of these, managing these 7 or 8 different components in different locations, each has a different management model, making the day 2 operations very difficult. So it's an appliance management model, right? Third thing is, once you've deployed it and configured it, the next thing is operations, the day 2, the observability. Each of this takes a long time for you to go and observe what the problems are with the application and look at what the challenges are. So for example, if there is a problem, right, if there's a latency to your app is high, or a particular application is being blocked, you need to go troubleshoot using multiple panes of glass, right? You need to look at your DDoS portal to say, are you being attacked? Then you look at a router saying, is my routing correct? Then my firewall, is my port open? Then my load balancer, is that blocking it? Is that not connected to the upstream? Look at the firewall, is my web application firewall, is that blocking it? And then look at my API gateway, and then look at my Kubernetes Cluster to see is my traffic actually reaching it, right? So there's multiple panes of glass that you need to go to in order to troubleshoot an application. Then look at day 3. All right, I set it up, things are working. I can troubleshoot. It takes longer, but all right, I'm actually getting to work. The next thing is, okay, how do I keep all of these up to date? How do I upgrade them? How do I do the entire life cycle management of these different components? That results in another set of complexity, right? And then The fourth point is, as I said, this is not only in your data center or maybe in your large VPC public cloud. You're now looking at different locations because your app users want to deploy their services closer to where the data is being generated. This could be in the edge. This could be in a retail store. This could be on a manufacturing plant where you may not have the luxury of deploying big pieces of hardware and wiring them up together and having the luxury of doing that. And that is what the challenges are with some of these um, point products which people have glued together in order to deliver an application. What is required from a for a modern app is something that we call as distributed cloud, right? You need a way to distribute your application faster, which means you need to integrate all these different services into one stack. So there's one stack which you can use to integrate all these different things, and the stack can be deployed any which way in any location. This will then the next thing is the stack needs to be deployed in a way that it can be not managed as an appliance for every location. You're managing it as a fleet of locations. So you're creating your intent or your configuration once, and then wherever the thing is deployed, your configuration and policy just follows where it is deployed. That is what you need for a distributed cloud because your services are distributed. There's no reason why you have to manage each of these different app delivery components in a in a singular fashion. And then because it's an integrated stack, there needs to be one sort of observability portal where you can see the health of the system and of the user's request in a simple fashion. And then it needs to do the full lifecycle management that is completely managed so that it does not result in managing multiple components. And lastly, as I said, you need to be able to do it in a way that is deployed and managed in different locations simply by defining your configuration and intent once, and the intent that gets distributed to different locations wherever it is deployed. So let's take an example of what delivering a modern app looks like using the distributed cloud approach. So in this case, I'm taking an example of delivering the modern app publicly on the internet. So first, if you remember, we had a bunch of components over here, and you have all of these components. So in case of modern app, I'm not suggesting you to get rid of these components. What we are saying is you deliver this sort of an integrated gateway or application gateway, if you can call it, which what it does is it should have the ability to discover the app, right? So it should be able to discover what services are deployed already. Once it discovers the app, it should then have a control plane which distributes not IP addresses or routes, but actually distributes apps, services, and services reachability, as well as service health. And this control plane should distribute it in different locations, right? In this case, since we're delivering the app publicly, the control plane should actually distribute the app to a global network of POPs. So what we do believe is required is you need to have a global network of POPs so that you can actually distribute the reachability of the app to any of these different locations. Once you do that, then you should have the ability to advertise the app publicly, so you can decide which location the app can be exposed or can be advertised to. In this case, all we're saying is expose it publicly. So we're advertising the app on a public Anycast web virtual IP, which attracts users' traffic to it. Now, once you've done that, traffic can now flow from the user to the virtual IP that's advertised publicly, and then it is sent back to the origin here. Now you should have the ability to distribute specific cloud services closer to the user. For example, I may want to do SSL termination closer to the user rather than doing it from here, right? So by using a control plane approach and using a SaaS-based full lifecycle management, you need to define the intent, saying I want to um, configure my WAF or my SSL termination closer to the user. So you can distribute some security functions closer to where the user is, so that all of your application firewall blocking happens away from your data center, and this way it protects, it only sends good traffic here and keeps the bad traffic blocked right here. And then lastly, it should maintain a persistent connection to your origin. This way, while the user sessions may go up and down and you have multiple sessions, this session is persistent, so that there is no there's no overhead of setting up the TLS session. This is what we believe is an approach, a distributed cloud approach to delivering a modern app publicly. Now let's take the same example of, in this case, not delivering the modern app publicly, but delivering app privately using the distributed cloud approach. Again, now you have the same components on two different locations. One could be a data center, one could be a public cloud, or could be two different data centers, depending upon the use case. In which case, now you have the app. What they should do is, don't get rid of this. This rides on top of it, right? So it's an overlay. What this does is, you need to have this backbone so that you can connect different sites using a private connection. So you need, the global network should have private connectivity to all your different sites and your clouds. And now the distributed cloud should discover the app, discover all the services using its control plane. Now distribute app reachability, not only to your public but also to other sites and locations where you might need to consume your app. So it distributes the reachability and health to these different locations. In this case, it's distributing the health to this location. This then advertises the app. So now you're advertising the reachability to this app to this site and this site only, right? No site from here, no other site can reach this app, because the API or the app is delivered privately, which means only this site and this application can access the app. No other application can access the app because the reachability has not been exposed, right? And that is the true advantage of having a control plane to distribute app reachability, combined with policies such as an advertise policy, which says which location can access the app. And now, once you've distributed the app, then you can now decide to now distribute not only the app reachability, but also the cloud services. So for example, I may want to do an application firewall. So any traffic coming from this side, I want the traffic to be blocked right here, instead of the traffic being backhauled all the way here and being dropped here, right? So this way, I'm protecting my own data center from traffic coming from this side by blocking traffic right here. So I need the ability to distribute cloud services to different sites away from my centralized data center. And then this should be a completely private connection, completely maybe a layer 2 link, or maybe an L3 VPN link, or a VPN link, IPsec SSL over the internet, or a completely private layer 2 circuit between these different sites. So therefore, this global network should have private connectivity to these different data centers. And that is what the approach of using distributed cloud to deliver these apps both publicly and privately. That's what it looks like for the user. Now, what is the benefit or the advantage of doing that? Now, in the demo that Jakub would show next, Jakub would show how long it takes for him to actually do it using the distributed cloud approach. What he's going to show is that it takes a matter of few minutes to distribute an app publicly and privately. So now if you contrast that with the current approach that takes 7 to 12 weeks, it goes down from weeks to days to hours, right? So what is the impact of that? For DevOps, the impact is that they can actually deliver more services, right? So new services can be delivered faster, which means they can now deliver more services. So for example, earlier, if they, because it took 8 weeks or 2 months to 3 months, they could basically deliver, four releases in a year, which is like 3 to 4 services in a year. Now, if it's going down to hours or days, now they can deliver a new service almost every few days, every week, for example. Now they can actually deliver new services faster, which means now it is bringing the problem back to where the developer is, but it's the developer who has to deliver new services. So we took a case study of a tech company who was adopting multiple clouds, and what they found is they could actually go from delivering 3 new services to 11 new services, and that resulted in a top line growth of about $7 million. Second thing for the infrastructure teams, the network and IT teams, infrastructure and operations team, is that because there's a consistent operation model across multiple clouds, both the private cloud, public cloud, the number of teams. So earlier they had a different team, one for a private cloud, one for a public cloud, one for the firewall, one for the load balancer, one for the router. So 7 different teams. If you look at the number of people, they had like QA engineers and 10 DevOps in order for them to actually deliver this. So what, 25 people. What they found is by going to a consistent operational model, they went from 25 down to 5, right? And this results in a huge operational saving for them, which is about $5 million. The third thing is in terms of this is in terms of the troubleshooting. Whenever there was a problem or an incident that they had to deal with, it took them on average about 5 hours in order to debug it. It's about 300 minutes per incident because they had to go to multiple portals. So that was 300 minutes. But with using a distributed cloud approach, which is a single portal, and all of these different components on a single thing, so you can actually thread a user request from the point where the user where it hits the network to the end application. You can actually thread the request all end to end, and therefore the debugging can be reduced dramatically from 300 minutes down to maybe 15 to 30 minutes per incident. And that in itself, because the time saving saves about $1 million. So that is really the operational benefit of a distributed cloud approach, which is essential for modern applications, which cannot be done by your existing tools and existing vendors. I'm going to hand it over to Jakub to actually do the demo and show us what the actual tools he uses to actually deliver the application. So I'm handing over to.
Okay. Can you hear me?
Yep, we can hear you.
Yeah.
Yep.
Can you see my screen?
Yes, we can.
Okay. So I prepared a simple demo where I would like to demonstrate what Pranav said and show you how it works, so you see the real stuff and not just slides. So what I will be doing here, I picked very simple app. I didn't want to complicate it with big microservices app. So what I did, it's like good example is I took a WordPress. So in my case, what you will see is I will have vanilla Kubernetes cluster in a private data center. And my goal will be to expose it globally with DDoS protection, WAF protection, and we can also, I will also show you some tests how to protect it. So it's a simple app, 2 pods in Kubernetes cluster. And what I would have to do normally, what Pranav already explained, is to get WordPress out with all the stuff. My biggest issue, because I'm more of a DevOps guy, was always I was stuck on network tickets on this site, which is owned by network team, and it's usually a very complicated process to get something exposed, get the IP addresses, firewall changes, all that stuff. And on the other hand, you need to be pretty hands-on to bring the Kubernetes cluster with ingress controller, with let's encrypt certificates, and then configure some WAF rules in Nginx or similar. So it's so this is how I used to do it in my previous job in one company. Now, what I want to show is how we can do it in a different way. So I will still have a WordPress in my private data center, but I will plug their VM. In this case, it will be VM. It can be server, but it can be also pod with Volt Mesh, it's called, which is what Pranav introduced. And I will advertise it on Volterra global backbone. So to briefly describe what you will see is, first, I will discover the app. So through Kubernetes service discovery, I will learn what applications are running there, and I will choose which I want to use in my ingress. Then this will give me global control plane reachability automatically. So once I discover my app, I can expose application locally, globally, pretty much anywhere. Even if I have second data center, I can expose it there. So I will show how hard is it to do it. Then I will advertise it on my public. So I will use Let's Encrypt certificates and use HTTPS to expose my WordPress. You will be able to test it even on your laptop. And then I will do SSL offloading here and configure WAF, web application firewall, and I can show you how to configure rate limiting and bunch of other stuff. And all this should take 15 minutes. Maybe it will be slow, take longer. Depends how fast I will be. So let's start. So first of all, let me show you. I have Kubernetes cluster, and to just show you what I've got here is I have really just vanilla cluster. I'm using Calico CNI, basic Kubernetes. Inside I had to use some because it's on-prem. I had to use some local storage provisioner from Rancher, and I provisioned into default namespace, MySQL, and WordPress. So really simple. I took upstream manifest and I just applied them. Now, in the normal world, you would have to deploy also, let's say, Nginx ingress or traffic or any option other. You would set it up, but since this box is basically sitting, if we check the kubeconfig, this box basically sits in a private IP address. I cannot easily go and expose it on the internet, right? So I would have to have a cooperation with and then in networking infrastructure to give me some NAT, public IP, and all those things. Now, I deployed next to this server, I deployed Volt Mesh as a VM in this case. And if we go into the Vault console, which is a portal, you can see, you can actually see here, since I am based in Prague, I name it as a Prague box. So it's a DC Prague. And this DC Prague is basically a virtual machine which sits next to the Kubernetes cluster. So one VM is Kubernetes node and other VM is this Volt Mesh. It could also run as a pod, but this time I decided I will run it. I will run it next to it If we explore the site, just show you, I have some basic information like how much traffic is flowing, and I can see interfaces. We can actually check that outside interface. I can see traffic, some basic metrics. So this is from the box itself. That box is connected to two closest Volterra regional edges, in this case Paris and Amsterdam. So it automatically established two IPsec or SSL tunnels to the closest boxes, closest location. Sorry, and it's a one node. And what I want to show you is the IP address. So he sits on the 10.11.053. And my previous my cluster sits on 10.11.72, right? So it's the same network. So he sits really next to it. Now we will start with the services discovery, because first I need to discover what is in my cluster to be able to work with it. So we will start with something called service discovery. And we can call it DC Prague. First, I need to tell where I should discover. So I can discover virtual site. So imagine you would have 10 of such a sites or locations. I have just one. So I will choose site and I will say DC Prague. Now I can also say on which network I want to discover. So we have various networks. So in my case, it's a site local network. Then I can say we support Consul or we support Kubernetes. So I will say Kubernetes. If it is Kubernetes, I can paste kubeconfig or I can put the TLS parameters. So we will do kubeconfig. We support option of encryption. So it's kind of like encrypting your secret. I will not complicate it for this demo, and I will use clear secret. So basically what I will do here is I will just copy the kubeconfig and paste it into the box. Now I could do more stuff. I don't need to do only discovery, but I can also publish services. This is maybe for the different demo. And I can also choose what type of pod discovery I want. So just to explain, Calico supports BGP. We support BGP as well. So I can create some nodes as route reflectors, and I could directly peer with this box, and then I can go directly. If not, I will use node ports. If pod IP is isolated, like in my case, I will use node ports of the services for the reachability. So that's it. Let's save it. Now, if I refresh, you can see it discovered 4 services, and one of these services is our WordPress default. So just to show you, right? So this is the WordPress default. The only thing what I did is I have chosen node port because I can go because I don't have direct port reachability in this setup. So I have node port, pretty straightforward. Now, when I do the discovery, according to my slide, we did the step 1. Now we actually want to expose it globally. To expose it, I need to go to application namespace, and I have my namespace webinar. I call it webinar. Now we have there is many options, but what we are interested is HTTP load balancer, because we want to advertise the service. Now let's do the load balancer. So we can call it WordPress public, for instance. Now I need to say that I want HTTPS, and one thing what I do have here is domain delegation. So I can either bring my own certificate, or we support domain delegation. So for this demo, I configure domain delegation for the domain app vkts.io. So this is my domain which I own. Maybe I can show it. Give me a sec. Just show you what to understand. We have something like delegated domains, and here I basically delegated app vkts.io to Volterra, and I created these NS records. So I'm delegating. So now it automatically does let's encrypt and create DNS record for me. So in this case, I will call it WordPress. I want HTTPS and I want redirect. Now I want to advertise it on the internet. And in normal situation, I would configure origin pool, but because WordPress is a little bit more complicated, I need to use a custom route to do hostrev write. That I can show later if we will have time and explain why, but this is WordPress specific thing. To don't really touch WordPress config, I had to do custom route. So you can do simple route, but I'm going to do custom route, which I pre-created. I will show you, and that basically does X forwarded proto and automatic hostrev write. So I have routes. I have which is sending to the origin, and now I will be advertising on the internet. Now we are getting to the security configuration, and in the security configuration, I can actually configure WAF. In this case, maybe let's create first load balancer and then we will enable WAF. That will be easier. So this is the config. Now I will create it. Domain challenge verification started, and meantime we will check the we will create the origin pool. Origin pool is where actual service is running. So I will be using Kubernetes service. Service name is WordPress.default. This is what we discovered. And site is DC Prague. And discovery is on outside network. Port is 8080. You can double check, but it was, yes, 8080. This is the port. Local endpoints preferred. And that's it. So I have origin pool. And this origin pool, I have to link into custom route object. This is WordPress specific thing. So what I have in the custom route is okay, this one. Just to show you what I'm doing, I need to do this host rewrite to rewrite my app, and I'm also adding the request header with X forwarded proto. So this is the special thing for the WordPress to make it work. So now, if we check the load balancer, we can see that certificate is valid, virtual host is ready. So now, let's see. Yes, you can try in your browser. Maybe I can. There is a chat right window. So I can change to entire audience and anybody can open this link. This is the WordPress site which is served through our load balancer. Great. So we have a load balancer. Now I promised you to show how to do WAF, right? So to just enable the WAF on the load balancer, we have one more option in the security where I can specify WAF intent or WAF rules. Depends how advanced config you want to do. Intent is like a simple way to do it. Let me show you. So I can say WordPress WAF, and here I can just say it's PHP and it's a WordPress, and mode I can say block or alert. So if there will be attack detected in block mode, we will block the client. In alert, we will alert. I will show you in my demo. So here I will do the block part, and yeah, I have what intent. You can see we can do much more stuff, user policy, rate limiting, but I will be doing only WAF. Okay, saved. Now you can refresh and it still works. So to recap, what I did in this 10 minutes is I basically discovered WordPress, and then I advertised WordPress on TLS. So I'm doing SSL offloading, WAF configured, and I'm doing all global backbone. Now, let's take a look into monitoring part, because even if you set up all this in the traditional world, when there is an issue, you have very hard time to understand where the issue is. You need to build a really solid monitoring system and integration for all these components to make sure, for instance, where is your latency, or how IP address is flowing. And it's a not trivial thing. And my experience is that in case of issues, we spend sometimes even 3 hours to figure out where issue is happening, right? If it is on the firewall because there is something what someone configured wrongly, you don't have access, so you rely on someone else who is having access, and it's very painful. Now, in this case, it can be also hard, but it is at one place by default. That's the nice thing. I'm not saying that it's not hard to troubleshoot it. It is sometimes, but at least it is in single place, and you can see what is your latency from this place into the application. You have logs, you have metrics, and over a period of time we have also machine learning, which can tell you probability distribution functions and much more features. So now let's take a look on the monitoring and view part. So we have our load balancer. We can actually switch to this view, and we can see our load balancer, and we immediately see the clients, right? And we see unique visitor 6. So looks like someone really opened the link, because in last 5 minutes we have 6 unique visitors from Windows, Mac, and we can see that client latency is around 26 milliseconds. So this is where it reaches our point of presence. In this case, we can see it goes to San Jose, Paris, and London. Then it is around 117 milliseconds to the server, and then less than 1 millisecond to the application itself. So you see this. I see which browser, what TLS and anybody use, and I can continue. I can see the metrics. Now the request rate is pretty low, so actually let me do this. Let me generate some traffic. So I will be just generating some traffic, right? So we have better dashboards. Here we see the traffic, we see the origin. So origin is just one in DC Prague. Alerts, if we would have alerts. Request, so we can see how people are actually accessing the, let's say last 1 hour. How people access from what location. Let's check this one, right? We see the latency for this particular client, what is the device type. This was Safari and Mac, and it is from US, and this is his source IP. So we see this information, we can filter, we have something called forensic, so I immediately see what ASN, top source IP, top country. API endpoints we don't have right now. We would have to generate some patterns. Security, as we don't have any security events, real time as well. So now,
so Jakub, if I may just interrupt for one second. I think the point that, if I can just bring it back to a meta point, the meta point that you're trying to show here is, because of a modern app, you have an integrated stack all the way from layer 3 to layer 7. You can see the request and the metrics observability for all of those things. You're not going to multiple disjointed dashboards. You're getting everything in one dashboard, right? You're looking at both the layer 3 traffic, you're looking at layer 4 requests, you're looking at the URL, layer 7, you're looking at app firewall and all of that. So I think that's a great way of showing what was just discussed in the slides.
Okay, so now, because our time is going down, let me actually generate attack. So WordPress has something called WordPress scan, where you can attack on you can get some information, then you can do some simple stuff. So if I run this, actually this is interesting, because if you try this command on plain WordPress, it will show you information, but here you can see scan was aborted and response is 403, and this might be due WAF. So basically it is not even allow this. So let's do the random user agent. So it immediately blocked the scan. So random user agent will probably work. And now when I was testing it, actually we should start in few seconds. We should start seeing the, see, now there was already some rules were hit, and in a few see WAF security events free. So if we go here, you can see there are 3 security events right now. Immediately we can see my attack. So this is, I'm sitting in Prague, right? So you can see that it is from Prague. This is my source IP, what, and if I go deeper, I can actually see which WAF instance which rule was hit. It was blocked. Which rule ID, because WAF has rule IDs, and you can see all the information and why it was restricted very easily. So if I will run it multiple times, actually this app firewall dashboard should start showing. You can see it was trying to go dump SQL and debug logs and most common URLs, how you can actually dump WordPress and get insight, and we responded it 403. You can also see it here in the requests that there were started coming 403 and 404, 403 and 404 requests. And this dashboard, because it is taking, it's loading, few more minutes, it is taking last 12 hours, right? So we just launch it, so it takes a little bit to draw it, but you can see bot requests and all the stuff is getting here. So very easily, I have visibility into all the attacks and into one place, and in the metric I can, for instance, watch the request rate. So since I started generating here, you can see there is 1.6 requests per second generated right now. And if you would keep it running for longer period, you would see more data. There is also real time, I think. Yeah, we need more, little bit more time to show. But this is what I wanted to show as a part of this demo. I can probably hand it back to Pranav.
Yes, so I think we can open it up for questions. If you can go to the slide 18. Show my screen.
I think we have time for one or maybe two questions. We are very close to the top of the hour, so let's see what we've got in. Here's one question for you: is Volterra transporting the data between their data center through MPLS?
Yes.
Well, that's an easy one. Okay.
What was the question?
Yeah, so we have our own backbone. So I'll put it that way. We have our own backbone. So we actually have links, dedicated links between the different between the different data centers and different points of presence. And yes, and on top of that, we use essentially L3VPN in order to segregate every customer's or every user's traffic across the different things. So we have a way to do traffic engineering for different tenants on the backbone as well.
Okay, all right. We are about 3 minutes to the top of the hour, so unfortunately we don't really have any more time for question and answer period. But if you do have a question for either Pranav or Jakub, you can still go ahead and use the GoToWebinar control panel and submit the questions. The folks at Volterra will be getting a copy of all of the questions that come in, and I am sure that they'll be more than happy to follow up with you offline to get your question answered. A quick reminder to the audience that today's event has been recorded, including that amazing demo. So if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I did mention at the top of the hour that we would be doing a drawing for $25 Amazon gift cards. So without further ado, we'll go ahead and do that real quick. Our first winner today is Jeremy C. Our second winner today is Linda T. Our third winner today is David N. And our fourth winner today is Kevin D. Congratulations to our 4 winners. We will be following up with all 4 of you offline by email to get your Amazon gift card over to you. So please check your inbox. If you don't see it in your inbox, please check your spam folder. Pranav and Jakub, thank you both for a great presentation. Really, really fascinating stuff. And, you know, I love watching those demos. I make no bones about that. That's one of my favorite things. So thank you both. I appreciate your time and your expertise.
Thank you.
Thank you.
I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.